Hello Fun Nation, my name is James, here checking in with team number 2767 Stryke Force here at the West Michigan District event. Stryke Force brings the heat every single season, two-time world championship team, and they've done it again this year. They've got coral, they've got algae mechanisms, they can climb, they got custom swerve drives, so much more to dive into here with Stryke Force. Here I got Alex, Layla, and David. Let's find out more on Behind the Bumpers. All right, Layla, why don't you tell us a little bit more about your drivetrain here on Stryke Force? What makes you guys so unique compared to the rest of FIRST?
So our drivetrain is fully custom made. Almost everything is 3D printed. This is our 9th generation, so we've been working on this for quite a while. We have a built-in suspension system along with the frame where the drivetrain is connected through these bolts here, and the frame is chromoly steel, which allows a lot of flex.
So can you talk a little bit more about the climber and tell us a little bit more about how Stryke Force is climbing the deep cage here in REEFSCAPE?
So this is our climber this year. We attach it down with a servo motor. So can you hold this down here? So we undo the servo and then this flips out. Then with this ratchet system, we drive into the cage, and these two little prongs will grab onto the lip of the top of the cage. Then we also use these magnets with Teflon tape on top of them to help align the cage. Then with the ratchet, we'll pull this cord and pull it into the robot. And the one thing that helps us align correctly is the lights that we have on the top of our robot here, and then on the side will change color depending on how deep into the robot we need to be, and then that will pull it up.
Thank you, Layla. Very interesting to learn about. Alex, can you tell us a little bit more about some of the more coral and algae mechanisms on this robot, as well as your pretty unique lift in the middle?
So all of our coral and algae mechanisms are all around our biscuit, which is down here. It's a minion with a big old gearbox. It's a versaplanetary and a belt reduction for the arm, and everything mounted onto it. So we have this coral chute over here. It has a minion with a lightweight versaplanetary and a belted all with and then on the bottom there's these skates to be low friction, and we have these hoops to just have less surface area on the coral as it goes through. So first we have this big funnel. It's polycarb, and one thing that we have been doing is we don't cut through all the way as we're lightening it. We go to like 50-ish thousandths, and we make a really thin layer, and it leaves a lot of the strength with staying as a single piece. Also with the funnel, we have 3D printed corner brackets that make it all up if you want to look at it. So coral goes through the funnel into our mechanism, and it goes up for all the levels. The coral mechanism stays at a fixed angle through it all. Right next to it is our big algae arm. We have a minion with roughly an 8-to-1 through these belts that spins. This minion spins this wheel through all these belts. We also have a beam brake to tell when the ball is in, and I think that's it.
So
also,
I sense a theme with your robot. I see a lot of minions. You know how many minions you have on this robot?
3, 4, 5, 6, 7 or 8 minions.
Impressive.
Yeah.
It's cool to see how you guys use that. Can you tell me a little bit more about your lift? I see a lot of carbon fiber. What was the design process like that, and how did you guys select 3 stages, stuff like that?
So we've been going with the first time we used a carbon fiber elevator was maybe 18 or 19. We went to the carbon fiber elevator. But one thing that's new this year is we're the first time we're ever doing a continuous rigging elevator. So we have 40 feet of belt lifting it up. It's 5mm HDD by like 9mm wide. It's all carbon fiber, and we have corner brackets that are 3D printed, and they're actually only hot glued together. So if we need to change something, we can just heat it up and pull it apart. And then it's a 2-stage. We just went with 2-stage because we had to go really high for this game, and it was a good amount, I guess.
Well, thank you, Alex. David, can we talk a little bit more about some of the software here on 2767? What makes you guys so dominant in the field of play?
Absolutely. So this year in this robot, we've chosen to automate the coral scoring process. So all our driver needs to do is hit one button and the robot will drive itself to the correct position and score the coral. This is all made possible through our vision system, our custom vision system, Walleye. This is the second year that we're using it, and it enables us to do all of this stuff. In autonomous, we also have a very consistent 3-coral auton. This is also made possible through our vision system and our auto-supercylcing capability.
Well, thank you, David. I really appreciate that. Well, Team 2767, thank you so much for talking with us today. It's an honor. Best of luck throughout the rest of West Michigan as well as the 2025 REEFSCAPE season. Incredible robot. As for you, thank you so much for watching this episode of Behind the Bumpers. My name is James, signing off.